Okay, so in this video we're going to talk about probability, kind of introduce you to probability. So at the heart of probability is randomness. You know, we use probability a lot when we go gambling. That's how people in Vegas make their money. It's how the dealers make their money. It's how the winners make their money. It's all about probability. It's all about the randomness. Flipping a coin, drawing a card, etc. They're all random processes. There's no skill to it necessarily, but it's all part of probability. So there's two types of probability. First one is experimental. Experimental probability are probabilities based on real-world data, such as insurance companies have probability of the age of drivers in an accident. And one of the pieces of data they have is that there are more 16-year-old drivers in accidents than there are 36-year-old drivers in accidents. And there's a lot of reasons behind that. But this is an example of experimental probability. It's based on real-world data. The other type of probability is theoretical probability. It's not, you can find this without real-world data. For example, rolling a die. You know that there are 6 sides to a die, and somewhere within that 6, you're going to get a 1 in 6 is probability of each side. An even number would be 3 in 6. But you don't need any real-world data to figure out theoretical probability. Okay, so how do we calculate probability? So when calculating probability of something happening, that something is called an event. And we write it down, the probability of something happening as the P, or the probability of the event, and the event goes in parentheses. So for example, the probability of rolling a 3 on a die. Rolling a 3 on a die goes in the parentheses. Probability of winning the lottery. This is how probability is notated. Probabilities are always expressed as a number between 0 and 1. So in other words, you're going to get it as a ratio, then you're going to divide it out into a decimal between 0 and 1. Probability event that is certain to happen is 1. Probability of an event that is an impossible event is 0. And that's why all probabilities are between 0 and 1. Alright, to calculate probabilities, you're going to count the number of ways an event can happen, then you're going to divide it by the total number of possible outcomes. So we'd say that the probability of an event is the number of ways an event can happen, divided by the total number of possible outcomes. So let's look at some probabilities. If a bag has 4 blue marbles, 6 green, and 3 yellow marbles, we want to figure out these probabilities. So first you've got a total of the marbles. So we've got 13 marbles, not a space. So for each of these, for green, we've got 6 green marbles. So we can say we have 6 out of 13 chance of drawing a green marble. Now remember, I said it has to be a number between 0 and 1, so we're going to do 6 divided by 13. We find out the probability of picking a green marble is 0.461. What about a yellow marble? 3 out of 13 would be your ratio, and when you divide it, it should end up being about half of that. 230. What if we want green or yellow? Well, it's still out of 13, but now we're going to add the green and the yellow. So it's going to be 9 out of 13. When we get that, it's going to be 0.692. Okay, so this is a basic example of probability where I took the number of ways an event can happen and divided it by the total possible outcomes. So let's look at a little more. This time, I'm still going to do my calculating the same way. Number of ways it can happen divided by the total possible outcomes. But this time I'm getting my numbers off of this chart, off of a frequency table.
Oh, she made it video.
Sometimes called a contingency table. So, here we go. And this one's talking about drivers on phones and the number of accidents they have. So, we want to know the probability that a driver is a mobile phone user. So now there is a trick when you have one written like this to using it. So if you look for your little helping verb in here, in this case it's is, that helping verb tells you where to divide your data. So the driver is going to be your top number, and the mobile phone user will be the bottom. Or, sorry, backwards. The driver is going to be your bottom number, and your mobile phone user will be at the top. So let's look up here. So this is just wants to know a driver. So total in this chart, we have 755. And how many use mobile phones? 325. So what would we do? We would do 325 divided by, 755. We're going to get 0.430. So the probability that a driver is a mobile phone user is 0.430. So almost half. Now what about this one? Probability that a driver had no accident last year. So we've got had. Is our verb. So driver is going on the bottom. So again, 755. And the top, no accidents last year. So no accidents last year was 685. So if we do 685 divided by 755, we find out that 0.91 had no accident last year, or 91%. All right, here's our last one. A driver using a mobile phone had no accident. So our numbers are changing this time a little bit. Our denominator is going to be a driver using a mobile phone. So drivers using a mobile phone. So on the bottom is going to go 325 and had no accident. 280 is going on top. So we're going to do 280 divided by 325 to find out that 86% or 0.86 is our probability that a driver using a mobile phone had no accident last year.